This is Unit 8, Lesson 4, and in this lesson we're going to learn how to solve rational equations. So up until this point we've been working solely with expressions by simplifying and reducing them. Now we're making an equation, so we're going to have an equal sign and we're actually going to be solving, finding out what value x could be. So if you plug that back in, which value of x would make your equation true. Okay, so there's kind of two different methods. And it really just depends on the type of rational equation you're given. So method number one is when you have a fraction equal to a fraction, or most likely called a proportion. So if you think back to your middle school days, to solve a proportion, we cross multiply. So when we have that, we can simply cross multiply again. So if we look at the example number one, first, as always, it's important to set our restrictions because they really do come into play here a lot because we are solving for x. So if we solve and get a value that is a restriction, we have to reject that as an answer. So x cannot equal 0 or positive 2. All right, 0 because of this x and positive 2 because of that x. All right, so now I'm just simply going to cross multiply to solve. So I have 9 times x, 9x, equals 4 times x minus 2. And then let's just solve our equation. So we'll go ahead and distribute through. 9x equals 4x minus 8. Subtract 4x on both sides. 5x equals negative 8. So x equals negative 8/5 or negative 1.6. Okay. And then you do want to substitute it back in to check your answer, and it does work in this case. All right, well, what happens when it's not a proportion, when it's not a fraction equals a fraction? What happens like in method number 2 where you have a fraction plus a fraction equals a fraction? We can't simply cross multiply here. So we're going to take everything we've done so far and kind of combine it together. Our whole purpose now is to get rid of that denominator to solve. It'll be much easier. So first thing we want to do is identify what the LCD is. And just like we did in complex fractions, we want to multiply every single term by the LCD in order to get rid of any denominators we currently have. So if I list out my factors for my LCD, I've got a 3, I've got an x, I've got a 4, and I already have x written down, so I don't need it again. 3 is not a factor of 4, so the smallest number that those two can divide into is 12. So my LCD is 12x. So I'm going to go ahead and multiply every term by 12x. And I am going to write that there because it's going to help me see things. Now we're just doing a whole bunch of multiplying fractions here. So we've seen this before. We could multiply the numerators and then divide, or we could reduce first and then multiply. So for this first fraction, my x's cancel. The 12 and the 3 reduce to 4. So I'm left with 4 times x is 24. And my next fraction, the 4 and 12 reduced to 3. So I have 5 times 3 times x, which is 15x. And in my last one, my x's cancel, and I have 3 times 12, which is 36. Now notice I no longer have any denominator. So it's similar to adding and subtracting where I have to find an LCD first, but when I'm simply adding or subtracting an expression, I'm just multiplying the numerators by what was the missing factor. Here I'm multiplying everything by the entire LCD in order to cancel out that denominator. Okay, it cannot just simply multiply by a piece of it. All right, so now I solve my equation. Subtract 24 on both sides. 15x equals 12. Divide, and I have 4/5 or 8. I'm sorry, 0.8. Okay, and if you check that in, it works. Oh, I forgot to say my restriction, x can't be 0. I didn't get 0, so that's fine. All right, so let's take a look at the next one. Now this time, once again, I have a fraction plus a fraction, so it's not a proportion. But notice on the right side, that denominator, it's not factored. I want to factor it first. It wouldn't be wrong to not factor it and to treat the a squared minus 1 as its own factor in the denominator, but that's going to make it really long. So let's not do that. Let's factor it out, write down. I have an a minus 1 and an a plus 1. So that is my least common denominator. I'll go ahead and change the color to make it easier for writing. So multiplying everything by a minus 1, a plus 1. Kind of do your best to fit it all in there. If you need to go diagonal, go ahead. Okay, it'll make it a lot easier for canceling purposes if you write it out. All right, so for this first fraction, a plus 1's canceled. Remember, that's the whole point. I want to get rid of that denominator. So I'm left with 1 times a minus 1, which is a minus 1. Okay, in my next fraction, the a minus 1's canceled, which leaves me with 1 times a plus 1. Over here, they both cancel, which leaves me with just 2. Nice. All right, so we're going to go ahead and continue to solve. A plus A gives me 2A. Negative 1 plus 1, they cancel. 2A equals 2 and A equals 1. Now, my restrictions, when I go back and write them, tells me that A cannot be 1 or negative 1. But I got the answer as 1. But that's a restriction. If you were to substitute 1 back in, you would get a denominator of 0, and you can't do that. So therefore, it doesn't work. So what is my answer? I have to reject this. And since there is no other value, it's a no solution. So remember, anytime you solve an equation, you are going to get a number answer. You need to check to see if that number actually works. And if you solve and get a restriction, you know it's not going to work. You can plug it back into check, but it's not going to work. All right, let's try 3 more together, and then you can go ahead and try the last few on your own. All right, so this first one, once again, first of all, there is no restriction because I don't have a variable in the denominator, but I can go ahead and just cross multiply. So I've got 2 times x plus 2 equals 3 times 2x minus 4. That gives me 2x plus 4, 6x minus 12. Go ahead and solve. I'll subtract 6x on both sides, subtract 4, and I get a positive 4. And even though I don't have restrictions, I still want to plug that back into check. And it does work. 4 plus 2 is 6 divided by 3 gives me 2. On the other side, 2 times 4 minus 4 gives me 4 over 2 is 2. So the both sides check out. All right, in my next one, once again, I can just cross multiply. My restrictions here, x cannot equal a negative 1 or a positive 3, so I want to be mindful of that. So I've got 2 times x plus 1 equals 3 times x minus 3. So I have 2x plus 2 equals 3x minus 9. Negative x equals negative 11, or x equals 11. Not a restriction, and when you plug it back in, it does work. So you can go ahead and check that out. All right, the next one, okay? Don't have to factor any denominator, but I do need to write down my LCD. Okay, when it was cross multiplying, you didn't have to worry about that. But I've got a 2, an A, and an A plus 1. Remember, that 2 and A aren't attached because it's 2 times A. If you wrote them together in your LCD list, that's fine. I just want to make sure that we know that that's not like one component. All right, so this guy still has to be multiplied. Okay, every term has to be multiplied by the LCD, whether they start off with a denominator or not. So 2A, A plus 1, 2A, A plus 1, 2A, A plus 1. All right, so in this first one, there is nothing to cancel, so I have 4A times A plus 1 minus the 2A's canceled, 5 times A plus 1. Make sure we'll distribute that negative 5 through shortly. 2A times 2A is 4A squared. All right, so let's simplify that. We got 4A squared plus 4A minus 5A minus 5. My 4A's A squareds end up canceling, so if I were to subtract on both sides, they cancel out. So I'm left with negative A minus 5 equals 0. If I move my A over, I have negative 5 equals A. And that's not a restriction. My only restrictions here were 0 and negative 1. All right, so guys, to solve your equations, find the LCD, multiply every term by the LCD to cancel out the denominators. All right, please pause the video. I'm going to go ahead and do the work for the next 5. I'd like you to take your time and try those on your own. Make sure you factor your denominators first if they are factorable. Please pause the video now. Pause it. Do it. All right, go ahead and take a look. Nothing too crazy here. And the one in blue, I just multiplied everything by x to get rid of that denominator. And then it was a quadratic that was factorable, and I solved. In the next one, they had the same denominator, so they kind of just cancel each other out. And I was just left with 9. Now, the one in red's a little bit quirky where you end up with a quadratic that wasn't factorable. So you solved it. So what? It's an irrational number. It's still a value. So I had to use the quadratic formula to solve that quadratic. And I got negative 1 plus or minus the square root of 10 over 3. Last two are pretty straightforward. Make sure you factor, like I said before, that c squared minus 4 factors in the c minus 2c plus 2, and the x squared minus 10x, etc. factor. So please factor when you're getting your LCDs. All right, I'm going to finish up and move on to the word problem. If you need to pause the video to look at my work further, please do so, and then you can press play when you're ready to join us. All right, so the last one is just doing the same thing, but in a word problem format. All right, so it says the sum of twice a positive integer and 4 times the reciprocal of the integer is 9. Find the integer. So half the battle here really is that we need to go ahead and set up what that equation looks like. So let's start. It says the sum, so I'm adding two things. Twice a positive integer, so 2b or 2a, I don't care what letter you use. 4 times the reciprocal. So 4 times the reciprocal is 4 times 1 over b, or just 4 over b, okay, because it's 4 times 1 over b, which is just 4 over b, is 9. Is your equal sign. All right, so we can go ahead and solve this. Multiply everything by b. So I have 2b squared plus 4 equals 9b. 2b squared minus 9b plus 4 equals 0. So this is factorable. Two numbers that multiply to 8 and add up to -9 are -8 and -1. So I can group. So I have 2b times b minus 4 minus 1 times b minus 4. So we get +1/2 and +4. Now looking at it, my only restriction in the beginning was b can't be 0. And if you plug both these in, they do both work. However, do they work? No, they don't work. Okay, but even if they did both work, I'm automatically going to reject the 1/2 because if I read the original problem, it says it has to be an integer. So therefore, I'm getting rid of that as a choice because it's not what the problem's asking me for. Actually, it would work. If you plug the 1/2 in, it would still check out, but the problem is putting a restriction on what type of answer they want. They want an integer answer. So therefore, I have to get rid of that 1/2. And because a fraction is not an integer. So my answer is 4. All right, we are done. Make sure you try the practice on your own. You've got to do this. You've got to practice, all right?